Good afternoon. My name is Brian Finley. I'm the Principal Architect for Big Data Solutions at Lenovo. And today I'd like to talk to you about the Lenovo Converged Analytics Platform. The Lenovo Converged Analytics Platform incorporates SAP HANA and SAP Vora on the MapR Converged Data Platform running on top of SUSE Enterprise Linux. So together, this gives you the ability to extend your SAP analytics across your big data environment and still incorporate your HANA data. How many of you guys are familiar with Vora? Voracious, excellent, yes. So we have, and how many of you guys, if I were to say, can you tell me what big data is, how many of you would be comfortable saying, yeah, I can do that? Okay, we got one and a half, two, okay, great. So, I'm going to skip through the slides here. We'll get to this one, then we'll work our way backwards. Okay, so in a big data solution, and generally speaking when I'm saying big data, I mean things that have Hadoop at the center, but Hadoop does not necessarily equal big data. And in a big data environment, you have the ability to store data that gets replicated across all of the nodes in the environment. So in this case, we have a representation of the Lenovo Converged Analytics Platform with one HANA node and 5 Vora nodes. If you were to write a piece of data to one of the Vora nodes, then that piece of data would get replicated to 2 other nodes in the cluster. Okay? So, fundamental concept that's important for where we take this moving forward. Now, we do that for 2 reasons. One is for resiliency. Once that data has been replicated, we can lose any 2 nodes and still have 100% of the data. And then it gets replicated to another 2 nodes and so on. But the other reason is for application performance. In the big data paradigm, as distinct from the classic method where you, like in the classic method, you might have a relational database and then you have a set of application servers and they're separate. And to work on the data over here, you have to pull it over to here to work on it. You do things with it and then you write the changes back. And all that has to go across the network. And this is generally constrained to certain limitations of scale based on how much memory you can put into a node that's running the database, the disk subsystem that it's connected to, and so on. And so the organizations like Google, Yahoo, and Facebook that really started developing big data technologies needed to be able to scale well beyond that, and to be able to have it, make it geo-distributed. And so this is the methodology that they came up with. So now that you've got the data replicated, it's in 3 places. Now, in addition to being resilient, it also gives us 3 places where we can analyze it. So in the big data paradigm, instead of moving the data to the application server, we move the application to the data. So now we've got 3 nodes that have storage locally, but they also have memory and CPUs. So we move the application to where the data is that we need to analyze, and now we can analyze it on any one of those 3 nodes. But what if you could take that application and have it split itself into 3 and do 1/3 of the analysis on each of the 3 nodes? Well, if the job took 60 minutes running on one node, then now being split and 1/3 being run on each of 3 nodes, you can do the whole thing in 20 minutes. What if you've got 2 chunks of data, right? Now they're spread across 6 nodes. So you cut that 60-minute job down to 10 minutes, et cetera, et cetera. So this is some of the properties of scaling that are inherent to a big data solution. Now, Vora is an application from SAP that is designed to sit on top of the Apache Spark big data framework. So Spark handles, it's a framework. When you have an application written to work with it, that application takes on the characteristics of Spark, which include that when it has temporary data, like let's say that you're doing some processing and you've got multiple steps. At the end of each step, you have temporary data. That temporary data gets written to memory as something called a residual distributed data set. That chunk of data gets replicated to two other nodes in memory. So now, memory being hundreds of thousands of times faster than spinning disk, this allows you a significant performance advantage over simply putting it into the file system directly. And so matching up with SAP HANA as an in-memory database, SAP Vora gives you in-memory capabilities working with the data in your big data environment. Now, a lot of the data that's being generated today is unstructured. So the data that fits into HANA needs to be very well structured. It has to be a certain column type, and maybe it's a date string or it's a text file or a binary. It's got to fit into a certain type of data to make it into the HANA database. A lot of the data, something like 80+% of the data that's being generated today, is not structured, but there's value in it. And so let's say, for example, that you were a retailer and you have your ledger data stored in HANA in memory. Okay, so you've got the most important portion of your data in memory in HANA. But you also have receipt images of all of the transactions. Well, you want to be able to corroborate that what was in the receipts, what was handed to the customer, what happened at the time, actually matches up with the ledger. Maybe you don't need to do that on a daily basis, but it's important to be able to make that check. And it doesn't make sense to put all of that data into HANA. Image data does not compress very well, which is another one of the places where HANA gets its performance advantage, is by compressing the data. And because you're paying for the in-memory chunk, you're going to fill up that chunk very fast if you're pushing images into it. Keeping the images in your big data environment allows you to expand your storage capacity to hold those, and then using Vora to read in the image information and perhaps some machine learning from Spark to do OCR and extract the textual information from the images. And then you can use Vora to apply a structure to that data as a view, if you will, like a view from a table, right? But it applies the structure on read rather than making sure it's structured before it's written into the system. So it stays unstructured, but you have this representation layer that represents it as a structured table space. Now you have a table in Vora that you can do SQL queries against that's based on the data that's in those images in the unstructured big data lake. Now you can take HANA and run queries and do analytics, not just on the data in Vora, but on the combined table space between HANA and Vora. So you can literally have a single query that incorporates the data from HANA and from Vora, even like with a join. A third use case, so the first use case is HANA doing analytics on its own. Second use case is a combination of HANA and Vora. A third use case is within HANA you have this ability to have multiple tiers of storage. So you can keep your hottest data in your in-memory table space within HANA and then push your colder data out to Vora as a secondary storage tier. But the cool thing is, you remember how we were talking about Apache Spark and how it stores its residual distributed data sets in memory? So if you push the data from HANA into Vora, it stays in memory. Okay? It'll eventually get written to the file system as a backing store for persistence and resilience across boots and so on. But rather than going straight from in-memory to on-disk, you're able to go from in-memory to Vora, also in-memory, but across the distributed big data environment. And so that is the Lenovo Converged Analytics platform, incorporating, of course, our SAP HANA appliance and our 3650 big data nodes from Lenovo. Thank you. So, yeah, clap. I like clapping. So,
you all done?
Should I ask, are there any questions? You get bonus points for questions.
You were going to go back.
Oh yes, I will go back now. Thank you.
You're going to start over?
I got overexcited.
You got done so fast, you're going to do it again?
No, I'm going to go backwards. Like, my name is
Nayar Slide 8 really fast.
So, pretty impressive stats. We run SAP at Lenovo. SAP runs SAP on Lenovo.
I want to get some of those speakers for my house.
Yeah. Of course, we're running on SUSE Enterprise Linux as the platform. I'm not going to let you have it back yet. And we have the MapR Converged data platform. MapR provides us some really key capabilities through the file system. In a typical HDFS file system, MapR is different from the other big data distributions in that they do not use HDFS. They have a file system that is capable of talking HDFS to Hadoop applications, so it looks like HDFS. But if you're using an HDFS file system, when you put a file in it, and let's say you've got a file called monkey eggs, right? And keep it interesting, monkey eggs. And you put this file into the Hadoop file system through the Hadoop application, and then you go to the file system of a node and you say, show me the files, you'll see garbledy-gook blocks of data. You won't actually see a file called monkey eggs, because Hadoop is not a POSIX compliant file system. But MapR FS is. So it talks HDFS up to Hadoop applications, but files that are written in from Hadoop can be directly accessed by non-Hadoop applications. It also is able to take all of the storage from the disks from the local disks and the nodes across the big data cluster and represent them as a single file system, including the ability to provide a high availability NFS service on top of that can be used to store the data sitting in HANA. See, I told you I'd do it backwards. And so now, when you're using the big data environment with MapRFS as the backing store for your HANA data, if you need to expand by adding additional HANA nodes, you simply add the additional node, point it at the data store, and read it in. You don't have to reconfigure your existing HANA nodes. And it also, in a worst case scenario, let's say that your HANA node dies, and you've got to replace it, because the data has been written to this self-replicating file system, you don't have to go back and try and find the backup from a day before, right? How valuable is your HANA data? How much is 24 hours worth of data loss worth? So with this, when it's written to the file system, it's not only on the HANA box, but it's replicated amongst multiple nodes. So you have a very high degree of reliability and resilience for your data. You add your new HANA node, you point it at the data store, and up and off you go. And of course we have Vora on top to do all kinds of interesting analytics with the 3 use cases that we discussed. And here we are at the beginning. My name is Brian Finley. Oh, we already did that, okay. I'm done now.